This is section 4.3, logarithmic functions. And so in section 4.2, we looked at exponential functions. And exponential functions and logarithmic functions play very key roles with each other. And really, this section is about converting logarithmic functions into exponential functions and vice versa. And so really, this should be titled Converting Logarithmic Exponential Functions. But it does introduce logarithmic functions in this section, and I'm really going to do a lot of examples of converting exponential to logarithmic form and logarithmic form to exponential form, and also simplifying simplifying some of these logarithmic problems. That's most of this section. First thing I want to do is I want to give a little motivation to why we need logarithmic functions. And that need stems from exponential functions. So let me show you what I mean. Alright, let's say we have, so this is something you can do pretty easy. 5 to the x power, I need to give myself some more room here. 5 to the x power is equal to 5. So what is x here? 5 to what power gives you 5? That's pretty easy. You can tell me x is equal to 1. Alright, what about this one? 5 to the x power is equal to 25. Well, you could tell me right off the bat that that is 2. So we can agree that 5 to the x is an exponential function. We just looked at that in 4.2. The base is greater than 0 and it's not equal to 1, and the exponent is a constant real number. Alright, so let's look at another exponent. Let's look at 5 to the x is equal to 60. Now, what can you raise 5 to so that way it gives you 60? Think about it for a second. There's no integer number you can come up with. It's a decimal, and it's a weird decimal, and we don't really have a way of figuring that out. So what we would do from this point up until this point, when we're solving for x, which is what we need to do in this case, we would multiply, divide, add, subtract, whatever we need to do to get x by itself. But here we're stuck. We don't know what to do because that exponent is, the variable is in the exponent, and we don't know how to get that out of there. And the way we get the variable out of the exponent is by using logarithmic functions. So that is where the need for this section comes into play. It's going to show us or allow us to solve this for x. So the first thing we need to know is how to convert from something of this form, which is an exponential form, into logarithmic form. And then we're also going to need to know how to convert backwards from logarithmic to exponential. And that's what this next definition is telling us. Alright. Alright, so here is a definition of a logarithmic function. If x and b are positive real numbers, such that b doesn't equal 1, then this weird looking thing, y equals log base b of x, that is what we're going to call, that is what we're going to call the logarithmic function of base b. That's how you'll write it. Is called the logarithmic function base b, where I'll go ahead and erase while you're finishing up writing that. And I'm going to talk about it too real quick. I'm not done with it. I'm going to finish it over here. But this is the key part of how to convert what I'm about to write on this side. So if x and b, here's b still represents our base. If they're x and b are positive real numbers, such that b is not equal to 1, then this is the logarithmic function. The logarithmic function base, where, so there should be, this should say base b where, and then here I'm going to write how you convert from exponential form to this logarithmic form and vice versa. So we're in logarithmic form, we say y is equal to log base b of x, and what I'm about to write, you can say it's the same thing as saying is equivalent to. So, but I'm just, it's a, I guess you'd call it a bold double arrow. So what that's representing is this as this is equivalent to this, or if you can go this way or this way, and then over here is our exponential function, b to the y power is equal to x. So to kind of label what's going on here, this is the log side, logarithmic. I'm going to start just writing log from now on, but that's the logarithmic side. And if you're in log form and you want to convert to exponential form, and so this is the exponential side. If you're in exponential form, which we were on those first examples with 5 to the x equals 60, then to solve for that variable, or the exponent, excuse me, you would convert to logarithmic form. Alright, so now let's look at these a little bit longer, and it will help. This will help a little bit when we get to the real examples. Alright, so let's start with something we're more familiar with. We're more familiar with exponential form, or something of this form at least. And so tell me what this b represents. What does b mean or stand for? So b is our base. We should also be pretty familiar with that. So nothing new really there. And what about this thing here? What is that? The y. It is the exponent. So this is our exponent. And that's partly how you know you're in exponential form, because your variable is in the exponent. And then over here we can call this thing the answer. As long as you know b and y, as long as you know your base and your exponent, then everything else is going to fall into place. And when I show you some examples here in a minute, that's going to make more sense. So I'm really only concerned that you can identify what's the base and what's the exponent. But for now, I'm just going to go ahead and say that this thing over here, I like to call it what's left over, but it's the technical answer, I guess, it's called the answer. But I'm going to refer to it as the leftover, as what's left over. That's, you probably can't read that. Okay, so now we're in exponential form and our base is here, this b. So when we're converting to logarithmic form, all we need to do is identify where that base is over here. So this b here is the same b over here. So this is our base. So whatever number this is what goes here now. And our y was the exponent. So over here on the equal sign all by itself is the exponent. So whatever number or value or a variable you have in the exponent, that's what goes over here. And then what's left over is this x. So whatever's left over is what goes there. And that log it's part of the formula, if you will, of converting from exponential to logarithmic. So it gets added in there. But take a note here of what we're doing. We have b to the y is equal to x. This is similar to the first example that I showed. 5 to the x power is equal to 60. I needed some way to get that exponent out of the variable out of the exponent. So when we go to logarithmic form, now I have that variable all by itself on one side of the equal sign. So now we know that this variable is equal to this thing. So let's look at some examples and it will clear up some of what I'm saying. Alright, example 1. Write in expo form. Expo meaning exponential. Write in exponential form. And here's part A. So if I'm asking you to write it in exponential form, that means we're starting in logarithmic form. And let's do this example. Log base 2 of 16 is equal to 4. Alright, so we are in logarithmic form. And we want to convert this to exponential form. And so think back to what I just said about over here. There's only two things I care about when I'm working these. If I can identify these two things, then converting it should be relatively easy. Those two things were the base and the exponent. So we need to be able to identify those. So the base is pretty easy. You read this as log base 2 of 16 is equal to 4. Just like over here, this is log base b of x. So the base is always this little number or the little subscript on the log. So whatever this number is, whatever that little subscript on the log is, that's always your base. Alright? And then think back to what I said over here. We had this exponent part all by itself on the other side of the equal sign. So I guess as a shortcut way, think of it as if you have log in the equation, then what's on the other side of the equal sign by itself, that's going to be your exponent when you convert to exponential form. So this is your exponent. And if you know those two things, everything else falls into place. So watch me. So I look at this logarithmic function and I say, okay, what's my base? My base is 2, so let's write 2. Then what's my exponent? My exponent is what's all by itself on the other side of the equal sign, 4. So I know that in exponential form, my base is 2 and my exponent is 4. And then that's equal to what's left over. 16 is what's left over. And now ask yourself, does 2 to the 4th equal 16? And it does. that's how you convert them. And I'm just going to give myself a little more room here and write it up here. 2 to the 4th is equal to 16. So this is exponential form. And when I get to example 2 here in a minute, we're going to go from exponential form to logarithmic. We're going to do a couple more of these so we can get the hang of them. This is very important to know. This section is 4.3 and the next section 4.4. They'll get tied together in 4.5, and 4.5 is it's a long and it's a little difficult section, but what section 4.5 essentially will boil down to is knowing how to convert and knowing how to identify that you need to convert between logarithmic and exponential form. But I'll keep reminding you of that as we go along here. Alright, let's try this example. And I encourage you to pause the video because I'm going to be doing a lot of examples. I encourage you to pause the video and I'll do my best to tell you to pause the video. But if you think you can do this example, once I write it, then go ahead and pause it. But I'm going to just continue working it. Log base. I lost track of the one I wanted to do. I don't want to do that one. Let's do this. Okay, give it a try by yourself if you want. Alright. So first things first, I need to identify my base and my exponent. So my base here is 3. That's my base. Let's not do a line like that. That looks funky. That's my base. And here, that's my exponent. And then now I can identify that 9 is what's left over. So the way you start is, alright, what's my base? My base is 3. My exponent is 2. And then that's equal to what's left over, or the answer. And then ask yourself, see if you did it right. This is how you check. Does 3 squared equal 9? Yes, it does. Alright, let's look at a little funkier one, but not too bad. Part C, log base 10 of 1 over 100 is equal to -2. So this one, I'm throwing you a little curveball by giving you 1 over 100. But treat this exactly the same as you did part A. You need to identify your base and you need to identify your exponent, and then everything else falls into place. So let's do that. My base is here, that's my B. And then this is my exponent. I know that's my exponent because there's a log in here, and what's on the other side of the equal sign by itself, if it's by itself, is my exponent. So my base, I said, was 10. My exponent is -2. And that equals what's left over, 1 over 100. And here you need to check and make sure that this is correct, and it is. You have to remember we don't like negative exponents, so we take whatever's raised to that negative exponent and we move it to the bottom. So now you have, so this 10 to the -2nd power, you take 10 to the -2nd power, move it to the bottom of the fraction, and you make that exponent positive. So you're left with just a 1 on top and then 10 squared on the bottom, which that is the same thing. Alright, let's look at one more. I'm going to erase this, so pause the video if you need to keep looking at it for some reason. One more. I keep losing my spot here. D log base 7 of 1 is equal to 0. Pause the video if you want to try by yourself. I'm going to do it this time without labeling b in the exponent. As we do these, you need to get faster and better at them, because at the end of this section, that's what was going to be expected, and especially when we get to some of the later sections, some of these some of these simpler ones you need to start catching on to pretty quickly. It'll be helpful. You don't have to get super quick at them. Alright, so I'm looking here. I'm in logarithmic form. How do I know I'm in logarithmic form? Because the log's in here. That tells me that so if I read this, log base 7 of 1 is equal to 0. So when I read it, I'm already telling myself what my base is, log base 7. So 7 is my base, and then its exponent is what's over here, all by itself on the other side of the equal sign, and that's equal to what's left over, which is 1. And then you need to ask yourself, does 7 to the 0 power equal 1? Yes, it does. Anything to the 0 power always equals 1. Alrighty. Now let's move on to example 2. And that is going to be right in logarithmic form. So what right in log form. And this is example 2. Alright. In part A. Let's say we have this. 3 to the 4th is equal to 81. So it's pretty obvious, yes, 3 to the 4th is equal to 81. And there's really nothing that we have to do here. But the point of these exercises is to get comfortable with converting back and forth between exponential and logarithmic. That's going to be very key in a little while. So let's convert this into exponential form. Logarithmic form. And we're gonna start out kind of the same way that we did on the previous example. We're gonna ask ourselves, what's our base, what's our exponent, and what's left over, which that just falls into place by default. So this 3 is my base, this 4 is my exponent. Alright, so we have those labeled now. Is there some way else I can help myself here? We're in exponential, the directions say we're going to logarithmic form. So when we're in logarithmic form, we know that there's going to be a log in there, so we can go ahead and write that. So I know I'm going to logarithmic form, and I know that there's going to be a log in here. There's going to be some base, there's going to be some leftover, there's an equal sign, and then this is going to be the exponent. So take it step by step. I know that there's going to be a log in here and an equal sign, so I'm just going to go ahead and write those in. And now I'm going to fill in the blanks. Let's do the easiest one first, or what I think is the easiest one is the base. Log base b, which b up here, my base up here was 3. So let's just write 3 in. Almost there. And then I forget which one this is, but I know when log's in here that the exponent is over here by itself. So this is my exponent, which is 4. And then what's left over is 81. So log base 3 of 81 is equal to 4. I know it's a little weird. It just takes some practice, but once you see it and get the hang of it, these things go pretty fast. All right, give this one a try. I want you, when I write it, I want you to pause the video. Two to the fifth is equal to 32. Okay, pause the video and give it a try. Alright, so my base here is 2. And then 5 is my exponent. This is where I miss having y'all in class, because you always speak up. This is part B, not C. Alright, so I'm in exponential form, and I know I'm going to logarithmic. So I know there's going to be a log in here, and I know there's going to be an equal sign. Alright, so log base B, that's always given. So the little subscript is always your base. So that's 2. I forget, this is the exponent. It's always by itself when logs in. So the exponent's 5. And what's left over is that 32. Log base 2 of 32 is equal to 5. Alright, let's try one more, and then we're going to move on. Part C. Ten to the 6th power is equal to 100,000. Oh, excuse me. No. Should be 1,000,000. Alright, pause the video if you want to try it. This time I'm going to work the problem without labeling everything. So I know there's going to be a log in here and an equal sign. And give myself a little more room for this equal sign. Alright, my base up here, so it's 10 to the 6th power. So 10 is my base. And I don't know, I forget. There's a log in here, so I know I'm solving for the exponent. I need it by itself here. And what's left over is this 1,000,000 that I didn't leave enough room for. Alright, hopefully this is getting a little clearer, at least how to convert. We're going to look at how to actually, we're going to change it up a little bit and how to actually solve something in log form. Okay, and what I mean by solve something in log form, this is what I mean. Let's do a new example, example 3, and we're just going to say evaluate. And here's part A. Evaluate log base 4 of 16. So notice the difference in this problem than the previous ones. In particular from example 1 when we were converting from logarithmic to exponential. What's missing is the equal sign here, where it gave you the exponent. Here it doesn't give you the exponent. It just gives you this log base 4 of 16. And it wants you to tell, what it's asking you is to find the answer of this, which it seems kind of weird and not sure how to do it. But you do know how to do it. And it's the all-important thing I've been telling you about, is you have to be able to understand when you need to convert from logarithmic to exponential form. When we get to section 4.5, this is what it boils down to in the very end. You need to realize you need to convert from logarithmic or exponential form. And that's what we need to do here. So this isn't set equal to something. It's not equal to some exponent. So what I'm saying to do is, if it's not set equal to something, then you set it equal to something. Set it equal to whatever letter you want it to be. So I'm going to say log base 4 of 16, and just pick a letter. I'm going to pick Y. It's usually standard what's used in these types of problems, but I'll mix it up a little bit and use something else. So now this Okay, so for this next example, I'm going to show you 8 to 10 problems roughly, and I'm going to work them out longhand, exactly the same way I did examples 3 and 4. That's what I'm calling longhand, even though it's only 3 steps. And I'm going to work them out longhand, and together I want us to try to identify the shortcuts. And I'm not a big proponent on just remembering everything, because that's not going to help you in the long run with some of this stuff. So I want you to know how to do the long way. And again, the long way is still short. It's 3 steps. But if some of these shortcut ways start popping out to you, and you start realizing it, and you start getting better and faster at these, then I encourage you to use these short ways. But take this as practice. Take it as learning. Let's look at this. Is example 5, and we can call it simplify, evaluate, something along those lines. But here's part A. Log base 3 of 3 to the 10th power. So you could take a guess at what maybe the answer is going to be. Maybe you can get an idea already of the shortcuts here. But let's just work it out longhand, the way we've been doing it, and see what happens. So we have log base 3 of 3 to the 10th is equal to y. My base is 3. My exponent's y. That's equal to what's left over, 3 to the 10th. So y has to equal 10. So that's telling you that this log base 3 of 3 to the 10th is 10. Think about it for a minute. Do you see a shortcut here or anything that pops out to you? Notice that this up here was your answer. So what happens is when you have log base 3 and then this is also the same, these cancel out with each other and you're left with 10. So again, I'm not asking you to remember these, and I don't want you to remember them. I want you to work them longhand, and as you become more and more familiar with them, that you can start recognizing some of these. Alright, let's look at part B. And this should look similar to the example we just worked in the previous example, except it was ln e to the 4th power. Here I'm using 2. So let's work it out longhand and see if what pops out to us. So natural log, and again, I'll pause the video at any time so that way you can get practice. Don't just feel like you have to rush through these videos. Please pause it. Try to pause it and try to work this one right now. So we can rewrite ln as log base e and then e to the 2nd power, and we'll say that's equal to y. Remember, this natural log became this portion here. Now we're in logarithmic form, so my base is e, my exponent's y, and then what's left over is e squared. So y has to equal 2. So what that's saying is this has to equal 2. Alright, let's come back up here though first. Let's look at this step and see how it relates to this messy one over here. Notice that that this base was 3 and this was 3 and our answer was 10. Same thing here. Our base was E and this is E, and then this 2 was our answer. So this still holds, but then we can take it a step further. When we have the natural log of E, when we have natural log E, these are actually inverses of each other, which inverses we learned in 4.1, but we only cared about just learning how to do them. So the natural log in E, when you have them in this form, in this way, cancel each other out, or inverse of each other, and they become 1 basically. So your answer is 2. Again, don't sit here and try to remember all these. That's not the point. Alright, part C. Log base 11 of 11. Well, if you're catching on to the shortcuts, you could see that if there's not an exponent written, there's a 1 there. We just don't really write it. So 11 and this 11 cancel each other out, and your answer is going to be 1. Now, if you don't see that, that is perfectly fine, and I'm okay that you don't see it. In fact, I'm more of a proponent that you do the long way anyways. So let's do it that way. Log base 11 of 11 is equal to y. My base is 11. My exponent is y, and that's equal to what's left over, 11. So y has to equal 1, which is what we set up there. Hopefully that's starting to come out faster for you. Alright, let's look at D. What about log 10? Pause the video and give it a try. Think about it. Think about it for a couple minutes before you just give in. Alright. So there's no base written here. What does that mean the base is? Hopefully you said or thought 10. And some of you, if you're getting the hang of this, log base 10 of 10 means these 10s cancel each other out, and the answer would be 1, similar to what we just did over here. But let's work it out. Log 10 is equal to, let's call it P, just to change it up. It doesn't really matter what letter. Convert to exponential, so my base here is 10. My exponent is P, and what's left over is this 10. So P has to equal 1. Alright. E log base the square root of 7 of 1. Alright, pause the video, give it a try, work it longhand, and then try to think of what the shortcut is. I'm going to give a second so that way you have time to pause. Alright. So I don't know what this is, and that's okay. So you work all these, and if you don't know what it is or you're a tad unsure, do the longhand. It's literally 3 steps. Alright. So first step is set this thing equal to something. Log base square root of 7 of 1 is equal to y. Now convert to exponential. The base is the square root of 7. Exponent is y. And that's equal to what's left over, which is 1. So what does this exponent have to be so that way it equals 1? I'm giving a pause so you can think about it. this has to be 0. Okay. If you need, what I want you to do is to pause it if you need to and think about what the shortcut is on this one. Shortcut here is if this position, what's left over, is 1, your answer is always going to be 0. Again, you don't have to remember that. Just know how to work it longhand, and you do this 2 or 3 or 4 times, and you'll start to remember it just by repetition, which is the best way to do it. You'll remember it longer, and eventually you'll understand some of the background math going on. It just takes time. Now there is this next one that I'm going to work. Unfortunately, the best way to do it is, let's go ahead and write it. E, F, oh no, I'm getting ahead of myself, I'm sorry. F, natural log of 1. Give that one a try real quick and pause the video. Alright, so the natural log, if you don't know what the answer is off your head, let's write it out. Log base E. That's what the natural log becomes. And then this 1 is still there. And let's set it equal to y. Now we convert to exponential. So my base is E. My exponent is y. And that's equal to 1. So what does y have to be? Y has to equal 0. Same thing as we did over here. So the thing you need to key on is if you have 1 in this position, in the leftover position, then it's equal to 0. Which the 1 is in the leftover position in this part also. It's just the natural log is a little different than what you're used to. So you can note it here also that it would be 0. So several ways to do it there, or to think about it. This next one is different, and let's see if you can do it. And I want you to try to do it yourself. Think about all the things I've warned you about to remember to do. And it's not a big deal right now if you can't remember. But give this one a try. Pause the video and see what you think. Alright. So here, it's a little tricky. Because in the 5 is the base. And then in the exponent is a logarithmic form. So you're in exponential form as a whole. But up in the exponent is logarithmic form. So we need to treat this as an exponential, as we're in exponential form. So let's do that. I'm going to rewrite it just so I know what the original was. So 5 raised to the log base 5 of x plus y is equal to, let's call it m. So what happens is, we're in exponential form. This is the base. This log base 5 of x plus y is the exponent. And this m is what's left over. So let's label. This 5 is the base. And then this is your exponent. So we need to convert this thing to logarithmic form. That's supposed to say E face. Alright, so when we're converting to logarithmic form, I know that there's a log in here, and I know that there is an equal sign. So that's a good start at least. Okay, so I have a base. My base in logarithmic form goes, it's a little subscript here. So that's this 5. So over here, this is always the exponent. So my exponent was this log base 5 of x plus y. And then what's left over is this m. Do you see the answer? So this log base 5 is the same on both sides of the equal sign. What's different? This m and x plus y. So what that's telling you is that m has to equal x plus y. And that is your answer. This is your answer. It's telling you that this thing is equal to x plus y. Do you see the shortcut up here? The shortcut is if you have 5 and it's raised to the log of the same base, so you have 5 here and 5 here, those essentially cancel each other out, or inverses of each other, and you're left with the answer, x plus y. So that's a shortcut. Alright. Study hard, do the homework, and that's all I have for this section.